Hi, welcome to the IoTomatoes demonstration video. This is the schema of our platform. We have all the microservices, the database, a MongoDB database, our user interface that is made of the Telegram bot, a dashboard, and a simple HTML web page. Then we have the catalog and the two ports of our platform, the Nginx load balancer and the message broker. Then we have the consumer of our platform, for instance an employee of a company, and the devices, the sensor and actuators of all the companies. We have launched the platform with all the services in a different container. All the services are connected to the same virtual network, IoTomatoes platform internal, and we have there 3 logs of 3 different services. For instance, we have the service catalog. It is a web service that provides information about all the services in the platform. Each service must register themselves and refresh periodically. Then we have the resource catalog, that is again a REST web service that contains information about company and resources. It is also a service like others, so it must register and refresh periodically itself to the service catalog. Finally, we have the Telegram bot, that is a service and a MQTT subscriber. It subscribes to topic notification and forward to the users messages from the platform. This is our Telegram bot. We can start it and we can try to insert a new company. The Telegram bot will create a different object for each chat in order to have a normal conversation with the users. It asks you questions and provide example and answer in order to facilitate the interaction. For instance, in this manner we have inserted a new company. Then we have a lot of possibility, for instance asking the users of the company, myself, of the device, the fields, we can delete the company, change the plans and so on.
As we can see, this is our platform running, and this is the terminal of our cloud database service. As soon as the platform starts, the plant database is loaded onto the cloud database. The plant database contains all the useful information about the type of crops our platform manages. If you register a company with our Telegram bot, we can see that after a refresh cycle, our new company is registered onto the database. And if you delete it again after a refresh cycle, our company will be deleted from the cloud database. Our cloud database is an MQTT subscriber to all the topics of our platform, and through the notified function it stores all the company's data, classifying them first by field and then by device ID. For example, here we have a simulation of 5 devices between actuators and sensor and 2 trucks, which are publishing data in an XML format on 2 topics related to the company Patata Novella. Our service will then classify and store those data into collections corresponding to the field's number of the company. In fact, here in the Patata Novella database, we have 3 collections. Collection number 0 is used to store the company's tracked position data, whereas collection number 2 and number 1 are the company fields. Each collection contains a number of documents corresponding to the number of devices inside that field, and each document is a JSON file containing all the SNML messages related to that device ID. As we can see, we have our platform running. This is the Telegram bot, this is the Cloud Database Service Terminal, and this is the Localization Service Terminal. The localization service is a web service which lets the user visualize the path followed by the company's trucks during the day. By typing trace onto the Telegram bot, we will be prompted with a menu to select which truck we want to monitor. By selecting the first truck, to the localization service, which will collect the data about the truck's position from the cloud service through a GET request, and then we'll return a PNG image of the path followed by the truck during the day.
Smart irrigation and smart lighting services will start working when a given company registers itself and serves crops present in their fields by means of the Telegram bot. It's possible to easily visualize the status of the actuator in the specific field by means of the dashboard. In both services, the control strategy is executed every 60 seconds. As a result, the same command will be sent to all actuators on a specific field as a simple MQTT message. The sensor measurement of a specific field necessary for proper functioning of the control law algorithm will be obtained directly from MongoDB. Both smart irrigation and lighting services perform preliminary checks before applying the control law, exploiting some information obtained from weather forecast. In the case of smart irrigation, watering is allowed only from 8 p.m. to 11:59 p.m. For demonstration purposes, in this case, from midnight to 11:59 p.m. was considered as the time interval. Next, it checked whether the daily precipitation sum did not exceed the allowed limit for the specific plant in the field. In the case of smart lighting, illumination can only be activated from sunrise to sunset. Then it checked whether the cloud cover percentage is below a reasonable limit of 60% in order to avoid control in case of temporary light reduction. Only if these preliminary checks confirm further controls are needed, then the corresponding control law will be applied. In the case of smart irrigation service, an hysteresis control law is used, while for smart lighting a simple single threshold law is used. In both cases, the measure limits related to the specific type of crop in the field and used in the corresponding control law are retrieved directly from MongoDB. As we can see, once the plant has been selected, the service will return the result of their control algorithm. Of course, in case the control strategy determines that the actuators in the field are turned on, it will be possible to view the updated status directly on the dashboard.
The dashboard is a critical component of the user interface. It is designed to display important data in the Home tab, including the current weather forecast, the total energy consumption of the current day, and a map showing the position of trucks. Additionally, the dashboard provides a separate tab for each field of the company, where the status of the actuators is displayed, along with average values for each type of measure and related plots. The Consumption Manager is responsible for tracking the energy consumption of each actuator in the platform. It periodically sends to the cloud the amount of energy consumed from each actuator for further data and costs analysis. The Resource Manager is responsible for ensuring the accurate management of devices within the platform. It performs checks to verify the update, removal, and addition of devices, ensuring that the platform's inventory remains up to date and properly configured. In addition to the device management, the Resource Manager also updates the device lists of other microservices within the platform. By keeping all components informed of the current status of available resources, the Resource Manager ensures that the system runs efficiently and without errors. The fault detection is responsible for monitoring and analyzing sensor data to detect faults or anomalies in the platform. It receives data from the sensors and checks if the measures are within certain thresholds, depending on the type of measure. In addition to the monitoring of sensor data, it also tracks the awakened state of the sensors, so it is aware of whether the sensors are currently active and sending data or whether they are offline. In this case, it reports a warning message to the user.